In this video, we are going to explain how can you handle the coefficient of an identity. Sometimes there is some shortcut. You can substitute some certain value to make your calculation much easier. Or sometimes maybe there is no such kind of shortcut. You can simply substitute a single value of x to get some unknown. So I'm going to teach you a more general method first. Then later on I will tell you there is a shortcut here for you to get the value of m and n directly. So for any identity, there is whole left hand side, right hand side, and then I'll just simply give you some example of identity first. Very simple thing is x plus 2. If there is some identity which is no matter what is x, they are still the same, the only possibility is x plus 2. That means x term must equal to x term. Constant term must equal to constant term. This is the property of identity. It's different from x plus 2 equal to 5. In this case, x can only be 3 in order to make this fulfill this requirement. So this is called equation. But identity is talking about no matter what is x, maybe x is 1 or 2, left hand side and right hand side are always the same. So it's simply like some rubbish statement that everyone know. It's a little bit strange in common sense. So, or one more example, if I give you 3x squared plus 5x minus 4 identities to something, I can simply tell you that the conclusion is it must be 3x squared plus 5x minus 4. No other choice. Every term should be the same. So in question, usually they will tell you something like this. 3x squared plus 5x minus 4 is always equal to ax power 2 plus bx plus c. So what they want to tell you is they just simply use so stupid method to imply you that this is always equal to this. So you may just simply say, okay, 3 is equal to 8. And this term should equal to this term. So now also we know 5 is equal to b. Finally, the last term is equal to the last term here. So -4 is equal to c. So what they try to imply is this one. And this kind of technique to draw the conclusion is called comparing coefficient. Coefficients mean what is the number in front of the variable. So coefficient is 3 compared with a here. 3 is equal to a. That's how we solve the identity problem. So go back to this question. Left hand side, mx plus 4 squared and then plus nx minus 1 squared. And right hand side, you must handle that separately. Plus 28 plus 46. So we have 3 terms. That means the first coefficient should be 1, and then the second coefficient is 28, the last one is 46. But this is not easy to compare in this format. That's why our first mission is to change this one to how many x squared plus how many x plus how many. That's our target here. So we are going to expand the bracket. Is equal m and then x plus 4x plus 4x plus 16. Focus on one part first. So this is x squared plus 8x plus 16. And then we start doing this, x minus 1x minus 1x plus 1. So this is x squared minus 2x plus 1 here. Continue to expand the bracket. First bracket, mx squared plus 8 times mx plus 16m. Every term we are going to time m. Here, every term we are going to time n. And one more thing, I try to write in the second row. So, plus nx squared minus 2nx plus n here. If we conclude, I want to know, in short, that means how many x squared is come from this term and this term. We have m plus n bracket x squared. Similarly, we have 8m minus 2n times of x, and the constant is 16m plus n together. Now we can easily compare with what we have in right hand side. I copy down once again. RHS is 1x squared plus 28x plus 46. So we can draw our conclusion. Our conclusion is by comparing coefficient. We know that this one and this one should be equal. M plus n is equal to 1. This is our first finding. Second finding, we know that 8m minus 2n is equal to 28. The last finding, we know that 16m plus n is equal to 46. Generally, if we want to know m or n, then what we want is using two equations only, then it's enough to log the value of m and n. Now we have more than enough, so you just simply compare these two because it's look easier. So now we are going to solve the simultaneous equation. M plus n is equal to 1. 16m plus n is equal to 46. I'll try to subtract them, because if we subtract them, n minus n will give you 0. So I use 16m minus 1m is equal to this item minus this item, 46 minus 1. So it's 15m. M is equal to 3. We got the answer, m is equal to 3. So unlucky that this question is quite complicated. Usually, if you compare the coefficient, you may get one of the unknown directly. But this question is not very friendly. But just now I say that there is a shortcut, right? So I'm going to explain how you can use the shortcut to solve the problem. The shortcut is this always correct. That's the meaning of identity. Always correct, that means no matter what is x. So you can simply using different value of x to see which one will make your calculation much easier. I want m, I don't want n. So our mission is to find out, is there any suitable x will make this disappear, become 0. When x minus 1 equal to 0. So that's why we think about that. How about if we consider when x is equal to 1? Because I know that if I replace x by 1, then I don't need to consider n, since this one will give you 0 only. So I replace x by 1. M is 1 plus 4 square plus n 1 minus 1 square equal to 1 square plus 28 times 1 plus 46. So if we do so, this is 5 square. This is n times 0 square. Just like what I mentioned, this will become 0. So this is 25m, and if we add them together, this is 75. Divide both sides by 25. So that's why m is equal to 3. Sometimes, if you consider a certain value of x, it's much easier to get your answer. But this method do not guarantee you can use it in all similar question type. Maybe sometime you can't find a single value of x to make it simple like this. So you need to learn both methods.